Hello everyone, this is Vibhul Purohit and I welcome you once again to my YouTube channel. Now as you know, the title of this video is all about the molecular orbital theory of polyatomic species. Now if you remember, I've already uploaded the first video on this particular topic. If you have missed out, if you haven't watched it, no worries. You can find out the link of that particular first video in the description box of this video. Okay, you can go through that. In that particular video, I had explained to you about the method called as SALC. That is called as symmetry, adaptive, linear combination. Right? Now we are going for the application of that SALC concept. Okay, to the two important molecules. One is beryllium hydride and other is water. So we can also call it as hydrides of beryllium as well as oxygen. So in this video, we are going to talk about the bonding taking place in beryllium hydride molecule. So the steps are very clear to all of you, okay, as I've already explained you in my first video. So we go into the molecular formula of beryllium hydride. We'll go step by step so that you have the complete knowledge about the bonding taking place in this molecule. Beryllium hydride, the formula is BeH2. Two elements, beryllium in proportion 1 and hydrogen in proportion 2. So the first step is selection of a central atom. दोस्तों जब central atom की बात होती है तो सबसे पहले हमारे दिमाग में आता है क्या, एक पॉलीसेंटर्स भी होता है, लेकिन मैं जनरल बात कर रहा हूँ. So generally it has to be what? 1. तो कौन सा एलिमेंट proportion 1 में है? Beryllium. So we say the central atom is beryllium. The surrounding atoms, okay, the atoms which are going to surround beryllium are hydrogen atoms, or we also call it as peripheral atoms. So either we call it as surrounding atoms or we call it as peripheral atoms, and they are going to be what? Hydrogen. Okay, so the first step is clear, everyone. The selection of the central atom and peripheral atom. Alright, my dear students, it's very clear? Alright. Normally I tell my students as my friends, so I will use the word friends also. So central atom beryllium and peripheral atoms are hydrogen. Now what we do is we go into the electronic configuration. So beryllium atomic number is 4. We are not interested in the first shell because the bonding is only responsible more in case of the outermost shell. In case of D and the F, then we go into the inner orbitals, but then when it comes to the S and the PU block elements, we normally consider the outermost ones. So therefore we consider it as 2s2. That's it. अब इसमें दोस्तों क्या होता है, सेकेंड शेल उसका आउटरमोस्ट शेल है. अब सेकेंड शेल से शुरुआत होता है p ऑर्बिटल्स का. यानी यहाँ पर बेरिलियम में क्या हमें बोलना पड़ेगा कि p ऑर्बिटल्स है, 2p ऑर्बिटल्स आर प्रेजेंट, लेकिन उसमें इलेक्ट्रॉन्स नहीं. और इसलिए मैंने यहाँ पर नहीं लिखा क्योंकि ये इलेक्ट्रॉनिक कॉन्फ़िगरेशन. Try to understand this logic, my dear friends. Please don't say that in beryllium the 2p orbitals are absent. No. Electrons in the 2p orbitals are absent, but 2p orbitals are present, but they are weakened. ठीक है? Now hydrogen. There are two hydrogen atoms. यहाँ पे मैं specify कर देता हूँ. There are two hydrogen atoms. So we write it down as HA and hydrogen है तो we don't have any tension at all. This way. Okay, HA 1s1 and HB is 1s1. Right? So this is about the electronic configuration. So we have selected the central atom, we have selected the peripheral atoms, we have also gone into the electronic configuration of the combining atoms or elements. Now we go into the next part, and that is the construction. Now we don't get directly a molecular orbital right away. Okay, I have already explained you in SALC. Okay? So what we need to do is, first of all we go into group orbitals. एक बार ग्रुप ऑर्बिटल बन गया फिर हम मॉलिक्यूलर ऑर्बिटल फॉर्मेशन में जाते हैं. ठीक है ना? तो अभी ग्रुप ऑर्बिटल कैसे बनेगा? ओके, इट्स अ कॉम्बिनेशन ऑफ ऑर्बिटल्स ऑफ पेरिफेरल एटम्स. ओके, यानी इन अदर वर्ड्स व्हाट वी से इज कि ये जो है ये दो, ओके, दोनों के दिल मिल जाएंगे, ओवरलैपिंग हो जाएगा. सो 1s ऑर्बिटल ऑफ HA and the 1s orbital of HB combines. Now you know the general rule, and that is the number of orbitals combining, same number of new orbitals are formed. ये हम लोग ने hybridization में बोला था, molecular orbital theory में ये सब पढ़ा है आप लोगों ने in your lower classes. So we are going to continue with the same thing. So यहाँ पे there are two orbitals which are involved in combination. So obviously we'll be having two more orbitals. क्या नाम देना है इसको? Group orbitals. I cannot call it as a molecular orbital. I have to call it as what? Group orbitals, and therefore I get two group orbitals. Another thing also which I already told you now the first video, I am repeating this again and again, first video, यानी आपको समझ में आ रहा है कि पहला वीडियो देखना बहुत ज़रूरी है, ओके इसलिए मैं उसका जैसे मैंने आपको बोला है लिंक डिस्क्रिप्शन बॉक्स में रख दूंगा, तो अगर वो वीडियो अगर आप देखोगे तो फिर ये बहुत इजीली समझ में आ जाएगा. केमिस्ट्री इज ऑल अबाउट लिंकेज, इट्स ऑल अबाउट बॉन्डिंग. यस, सो यहाँ पे 2 ग्रुप ऑर्बिटल्स बनेगा. Now in this case the orbitals are considered to be filled up with electrons, and electrons have got 2 properties, the wave property as well as particle property. But when we consider the orbital distribution, we are going to consider the wave properties. Okay, so that means the properties are based on waves, it is dependent on waves, and therefore we call it as wave functions. Okay, तो इसका wave function क्या होगा, psi1 and psi2. Okay, ऐसे ये 2 wave functions हो जाएंगे. Alright, so these are group orbitals. We don't call it as a molecular orbital because simple reason is molecular orbital are those combination of orbitals which contains the orbital of each and every element present in the molecule. मॉलिक्यूल में जितने भी एलिमेंट मौजूद है उनका ऑर्बिटल इस कॉम्बिनेशन में शामिल होना चाहिए, तब जाकर हम उसको मॉलिक्यूलर ऑर्बिटल बोलेंगे. ओके, यहाँ पर ऑर्बिटल ऑफ द सेंट्रल एटम है ही नहीं. In this particular combination, you can see this very well. Okay, in this combination, you don't have the orbital of the central beryllium, and therefore I cannot call it as a molecular orbital. So therefore, I give a different word. Okay, that is what we call it as a group orbital. Sometimes, you know, we can also call it as a ligand group orbital. That is LGO. We can also say that. Okay, in many of the reference books, that is also being mentioned. But then, in simple words, I want to just make it very clear, and that is I won't call it as a molecular orbital because it doesn't contain the orbital of what? Oh yes, the central atom. Okay, so I guess this part is clear. Okay, now we now go into that why we are going into this term, you know, group orbitals or ligand group orbitals. Our ultimate aim is what? For the formation of a molecular orbital. Now why it is not called as a molecular orbital? Because it does not contain the orbital of the central atom. यानी अगर इस ग्रुप ऑर्बिटल के साथ ऑर्बिटल ऑफ द सेंट्रल में एटम को शामिल कर दिया जाए तो हमें क्या मिलेगा, मॉलिक्यूलर ऑर्बिटल. अंडरस्टूड दिस? सो द ग्रुप ऑर्बिटल हैज टू कंबाइन विद द ऑर्बिटल ऑफ द सेंट्रल एटम व्हिच इज बेरिलियम इन दिस केस, एंड दैट इज गोइंग टू रिजल्ट इन द फॉर्मेशन ऑफ अ मॉलिक्यूलर ऑर्बिटल. You getting it, everyone? But this combination is based on what? Similarity. Okay, similarity in terms of the shape of the orbital. Next is the orbitals contains signs. They contain lobes, and the lobes contain signs. Signs means direction. Once again, I want to say I had already explained all these things in my first video. Alright, so this is symmetry all about, this is similarity all about. So now what I'll do is, I'll show you the pictorial representation of the group orbitals and the orbitals of the beryllium. Okay, and then according to the symmetry, we will now try to club both of them and thereby resulting in the formation of a molecular orbital. Okay, so we try to do that. Okay, see how well you will understand that. Okay, so to begin with, I'll show the group orbitals. There are 2 of them, psi1 and psi2. Now whenever we talk about a group orbital formation, that means what happens is that we have a arrangement of this fashion. I label all this, so don't worry about it. Okay, ऐसे लेबलिंग कर देंगे हम लोग. यहाँ पर मैं लिखूंगा HA, यहाँ पर मैं लिखूंगा HB, यहाँ पर 1s और यहाँ पर 1s. अब ये s orbitals है, so it's very simple. Everybody knows that it's going to be spherical in shape. So I will be showing the spheres. Okay, all the spheres are going to be shown over here. Now the next point is, okay, how these are going to be related with respect to each other, okay, in terms of our directions. So I give you a very simple logic how to understand that. Okay, I don't want to go into much more of the technicalities and make you very complex because my videos are student oriented. Okay, my purpose over here that students should understand. They should not make any mistake, and at the same time the student should not mug up all these things. It should easily come up, okay, when they are writing the answers, okay, because that is what my primary purpose of making these videos are. Okay, it is going to be student centric, more student centric. Alright, so we go into this. How you try to relate this is, see, if I consider 2 individuals and let those 2 individuals be the best of the friends. Okay, they are the besties, we call it as. Okay, in your language, okay, you call it as besties. लेकिन दोस्तों कितने भी वो besties क्यों ना हो, लेकिन हर समय में उनकी सोच एक समान रहेगी क्या? जी नहीं, बिल्कुल नहीं रह सकते. Okay, they will not always think same way in all the situation, though they are the besties. Okay, there will be a particular situation where their thinking ideology will be different. But why they are called as besties? Because in majority of the situations, they think in the same manner. So what I want you to understand from this combination is the examples of besties. In majority of the combinations, okay, or majority of the situations, okay, they think in the same manner. Similarity. Okay, and in some of the cases they think in a different manner. The same thing has to be brought over here. In majority of the cases, we say that HA1S and the HB1S think alike, similar, same. So I show the sign. Okay, I want to be always positive, so that my students also will be positive. So that's why I always talk about the positivity. And let me tell you, when I write on positive over here, it doesn't mean that only in this area it is positive. No, because it is S orbitals, you know, they are spherically symmetrical. You must be knowing this. Spherically symmetrical मतलब क्या? Spherical तो है ही, plus वो symmetrical है. Okay, यानी the plus sign is going to be for throughout the sphere. ठीक है? So both of them have got the same sign. You can write on minus minus also, no issues. But then as I said, no, I'm positive enough. So let us be positive enough. Okay, तो ये हो गया first case. Majority of the times the two besties are going to think in the same way, and therefore both of them here have the same directions. But sometimes no. Okay, I think in the same other way and you think in the other way. It happens many times. Okay, so there we go into the opposite sign. So once again we go for positive, and then here we consider a negative. So in certain cases there is going to be what? Negativity and positivity. So opposites. And यहाँ पे there are same. So this is what the combination that we get for psi1 as well as psi2, which are called as group orbitals, and those are going to be formed by what? Hydrogen atoms. Okay, that's done. All right. Now we go into what? Orbitals of the central atom, that is beryllium. Now when you talk about orbitals of the central atom of beryllium, दोस्तों एक बात हमेशा याद रखिएगा, जितने भी orbitals मौजूद है वो हमें दिखाना है. अभी तक हम लोग ने इलेक्ट्रॉन्स के बारे में तो कोई चर्चा की ही नहीं है. हमें सिर्फ वही ऑर्बिटल्स डिस्कस करना है जो मौजूद है, जो प्रेजेंट है. तो वो बेरिलियम में बहुत इंपॉर्टेंट है दोस्तों. बेरिलियम में बोलोगे ओनली 2s ड्रॉ करने का, दैट्स द एंड ऑफ द डे. नो माय डियर फ्रेंड्स. ओके, मैंने आपको शुरुआत में बोला था व्हेन आई हैव रिटन द इलेक्ट्रॉनिक कॉन्फ़िगरेशन दैट इन केस ऑफ बेरिलियम अलोंग विद 2s देयर आर गोइंग टू बी 2p एज वेल. ओके, तो 2p ऑर्बिटल्स है, इलेक्ट्रॉन्स नहीं है, लेकिन मौजूद तो है ना. यस. अभी जब 2p ऑर्बिटल्स की बात करते हैं तो दे आर डायरेक्शनल इन नेचर. ओके, इट इज 3 डायरेक्शंस. ओके, वी टॉक अबाउट स्पेस. सो ये हो गया z एक्सिस. दो पार्ट होता है हर एक एक्सिस का, आपको मालूम है, पॉजिटिव एज वेल एज नेगेटिव. द नेक्स्ट वन वी हैव इज x एक्सिस, एंड द थर्ड वन, okay, the 3-dimensional one is the y axis. So the p orbitals have lobes, 2 lobes along with a particular axis, and accordingly we have px, py as well as pz. आई बात समझ में? Right. So हम शुरू करते हैं अभी orbitals of central beryllium. तो सबसे पहले तो हमें 2s दिखाना है. Okay, I start with the positivity, so 2s. Okay, then as we go for the bonding axis is going to be z, so we show a bonding axis like this. Okay, because this is a z axis, you can check it out over here. So there are 2 lobes. क्यों 2 लोब है? यहाँ पर 2 लोब क्यों है? मैं हमेशा पूछता हूँ मेरे बच्चों को कि ये 2 लोब क्यों है? तो बहुत लोग है ना, स्मार्ट है ना, रिसेंट जनरेशन, बोलते सर 2 क्यों है? तो बोलते एक है इसलिए, एक नहीं है इसलिए. अभी मैं बोलूँगा एक क्यों नहीं है? सर 2 है इसलिए. Okay, anyways, it was just a joke. Now the reason is why there are going to be 2 lobes is because they don't have the same sign. Had it been the same sign, they would have combined together and they would have represented as one. लेकिन ये दोनों का लोब्स का साइन अलग अलग है. आई बात समझ में? आप दोनों का लोब का साइन अलग अलग है, तो साइड सी बात है, एक होगा पॉजिटिव और दूसरा होगा नेगेटिव. ओके, तो ये हो गया 2pz. आई बात समझ में? अभी इसको रोटेट कीजिए थोड़ा. सो फ्रॉम z if we rotate, we go towards the x part. ओके, तो अभी हम लोग x की तरफ जाते हैं. सो when you go towards the x, this is what we get. ओके, ये x axis है. Okay, this is the z axis and these are going to be the x axis. So the way we rotate it, we have rotated in this direction, so the lobe also gets rotated. तो उसी हिसाब से sign rotate करो. So plus at the top, minus at the bottom, and we get over here 2px. Okay, next one is we rotate in such a way now that one of the lobe comes front and the other lobe goes back. 3 dimension है दोस्तों. Why? Okay, y is not in between x and z. वो दिख रहा है ऐसा आप लोगों को कि वो x और z के बीच में, ऐसा नहीं है. वो आगे पीछे है. Okay, तो Z is left right, X is top bottom and Y is front and back. तो वो हम लोग Y में हम ऐसे दिखाएंगे. Okay, this is the way we are going to show it. Okay, ये back lobe है और ये front lobe है. This is 2py, this will be plus, this is minus. ठीक है, this is what all the orbitals are. ठीक है, of किसका central atom है and that is going to be what beryllium. These are the group orbitals. So orbitals of the central atom, orbitals of hydrogen, that is group orbitals. अब ये दोनों का जब मिलन होगा, ये देखो ना, ये दिल धड़क रहा है. Okay, that results in the formation of our molecular orbital. ठीक है, वो अभी कैसे होगा? So similarity के basis पे. So see now how it is. Try to understand. Let us consider the z-axis as the bonding axis. Okay, tension नहीं ले पाने का है. Okay, tension लेने का भी नहीं, tension देने का भी नहीं. Okay, so let us consider the z-axis. So we are going horizontally. So when these two are approaching horizontally, psi 1 देखो, psi 2 नहीं देख रहेगा. देखो आप वापस psi 2 की तरफ देख रहे हो. Okay, psi 1 पे देखो. Okay, ये जो दो lobes हैं, okay, try to approach each other horizontally. So when they approach horizontally, both of them have got the same sign. That means same direction. So obviously both will go together. So they will combine with one another. Okay, with a positive sign. So which is that orbital over here on the central atom which has only one lobe with a positive sign? कौन सा वाला है? आप देख सकते हो ना, spherical भी होना चाहिए, one single lobe होना चाहिए. यहाँ पे तो everywhere there are two lobes, so all these three are out of the option. तो बचा कौन? ये. So 2s is going to combine with psi 1. This is, my dear friends, the first combination. And what is this going to give you? What is this going to give you? Yes, the molecular orbitals. So your first combination, I guess you understood. 2s combining with psi 1 resulting in the formation of what? Molecular orbitals. कितना मिलेगा? 2. As usual. Because this psi 1 is considered as 1 and 2s is considered as 1. So 2 of them are involved. So how many you will be getting new orbitals? 2. The concept remains the same number. Alright. Now 2 molecular orbitals will be formed. अब उसमें से जब number of molecular orbitals are same, but the energy levels are different, my dear friends. Okay, and two major ones, total there are 3, but the two major ones are what? Bonding and antibond. Bonding means what? It is going to help in the process of bond formation. And antibonding means what? Okay, it is going to oppose the process of bond formation. Okay, just say it's very simple. In a classroom also, when we just go, suppose as a teacher, I go into the classroom and I tell my students that the Department of Chemistry is organizing a particular event. Okay, we need help from your side. क्योंकि जब भी हम इवेंट्स करते हैं, ओके, ज़्यादा करके स्टूडेंट्स के लिए, सो ऑब्वियसली वी रिक्वायर द हेल्प ऑफ द स्टूडेंट्स. ओके, दे विल बिहेव एज वॉलंटियर्स फॉर अस. So क्या हो जाता है उसमें कि there will be some section of the students, they will say, sir, you give us any work, we will do it. Okay, they will raise their hands. Sir, we are there to help you out. That is bonding. लेकिन कुछ और section of students भी है वहाँ पर जो ऐसा बोलना चाहते हैं, बोलेंगे तो नहीं, कोई कोई तो बोल भी देता, लेकिन कोई कोई ऐसा शक्ल ऐसा बनाते हैं कि वो ऐसा बताना चाहता है कि हमारी तरफ देखना भी नहीं सर. ठीक है, वो क्या हो गया? एंटी बॉन्डिंग हो गया. और बहुत सारे स्टूडेंट्स ऐसे भी होते हैं जो दे आर नॉट देयर इन द क्लासरूम, सो दे डोंट नो एनीथिंग व्हाट इज गोइंग ऑन इन द क्लासरूम, सो दे आर नॉन बॉन्डिंग मॉलिक्यूलर ऑर्बिटल्स. तो ऐसे 3 कैटेगरीज ऑफ स्टूडेंट्स हैं हमारे पास. One category of students, they are there to help the teachers in the activity going to be being conducted in a very smooth manner. Second category, don't you dare to look at us, that is anti-bonding. And the third category, they are not there in the campus itself, they are somewhere out, okay, enjoying their life in their own way. So that is non-bonding molecular orbitals. Okay, तो यहाँ पर हम लोग बात करेंगे when you talk about these 2 molecular orbitals they are formed, so they will be bonding as well as anti-bonding. बॉन्डिंग है, जितने ज़्यादा बच्चे लोगों ने बोला सर वी आर देयर टू हेल्प यू आउट, तो उतना देखो मोटिवेशन बढ़ता है वो टीचर का, बिकॉज देयर इज अ फोर्स ऑफ अट्रैक्शन, देयर इज बॉन्डिंग एंड दैट बॉन्डिंग रिजल्ट्स इन स्ट्रेंथ, बॉन्डिंग रिजल्ट्स इन स्टेबिलिटी. ऑल दिस एस, कैन यू रिमेंबर? स्ट्रेंथ एस, स्टेबिलिटी एस. तो एक और बॉन्ड भी एस से शुरू होता है, और यस यू गॉट इट, सिग्मा एस. ओके, तो इस तरीके से एस 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 याद रखने का, तो वो सिग्मा बॉन्ड बनाएगा. सो वन ऑफ देम विल बी अ सिग्मा बॉन्ड. Okay, and this is going to be 2s. हमें कौन सा ऑर्बिटल लिखने का है? The one which is of the central atom. Okay, so sigma 2s. Alright, because the central atom orbitals are changing. Na? The peripheral atoms, the surrounding atoms, hydrogen has got only one s orbital. The one which is changing is what? The central atom orbital. So please write down a central atom orbital over here. So in this combination it is 2s, so we get sigma 2s. So this is bonding. Anti-bonding, force of repulsion, मारा मारी, झगड़ा, बहुत एनर्जी चाहिए उसके. So it is instability. So energy level is high. Okay, so what we do is we make a star mark. You don't know white stars are up there in the sky. Okay, so please, this is what you need to understand it. Sigma star 2s. Okay, generally the stars are in the sky. नहीं तो कोई स्टूडेंट्स है ना वो बोल देते हैं कि नहीं सर ऐसा नहीं होता है ना हमेशा. Okay, मैं बोला क्यों ऐसा क्यों नहीं होता है, तो बोले कि आमिर खान की पिक्चर थी. Okay, तारे ज़मीन पर. तो वो कभी कभी हो जाता है, जैसे मैं बोलता हूँ ना हमेशा केमिस्ट्री में. ओके, जनरली ओके एक्सेप्शनल केसेस आर देयर. ओके, तो ये तारे जमीन पे वो एक्सेप्शनल केस है, लेकिन जनरली तारे सितारे कहाँ पर होते हैं? अप इन द स्काई. सो स्टार मींस हाई एनर्जी एंड दैट इज एंटी बॉन्डिंग मॉलिक्यूलर ऑर्बिटल. ओके, तो ये आपको स्टार और विदाउट स्टार से समझ में आ जाएगा कि विच वन इज बॉन्डिंग एंड विच वन इज एंटी बॉन्डिंग. So without star is BMO and with star is ABMO. This is the first combination you get. Okay, I just mark it like this. So that is going to give you a molecular orbital. Okay, next we go into side 2. Side 2 approaches each other. One is plus, other is minus. They say no, my dear. Okay, we cannot go together. Okay, because their directions are opposite. So when they approach to each other, all right, but then their signs are different, so they will still remain different. They cannot combine with each other, so they will remain as two lobes. और मैंने आपको बोला how they are approaching horizontally. तो अभी सोचो अभी. Okay, please concentrate on the words and concentrate on this diagram now. Okay, and that is in case of side 2, the two lobes are approaching horizontally, but because the directions are different, they cannot combine into one. They will remain as two separate. And because they are horizontal, so that means the two separate alignment will be, the orientation will be left and right. So left will be positive and the right will be negative. Now please check over here, where am I having two lobes with the left and the right positive negative? I'm using this word because this is all symmetry, it's all similarity, not only with respect to the number of lobes, not only with respect to the signs, but also with respect to the orientation of the axis. Okay, तो वो कौन सा मिलेगा अपने को? 2pz मिलेगा. 2pz has got two lobes horizontally, left and right, positive as well as negative, so this is going to match with this. So therefore we get a second combination, and that is 2pz with psi 2, and that is also going to result in sigma 2pz, and we have sigma star 2pz. Okay, this will be BMO and this is going to be ABMO. Okay, in this particular syllabus, please be very clear. Okay, that we are talking about sigma bonding only. There is no pi bonding in this particular syllabus. Okay, so please be very clear. Okay, and hydrogen is going to be involved. Hydrogen has got one s orbital. S, देखो वापस S आया. S orbital, S for sigma, S for strength, S for stability. Okay, ये सब याद रखो. Okay, तो गड़बड़ नहीं होगा कभी. So to be Z orbital is going to combine with psi 2. Okay, Z is a bonding axis, so obviously bonding axis you know very well, an axis along which the overlapping is maximum, right? So 2pz is going to combine with psi 2 and it is going to give you sigma 2pz and sigma star 2pz, BMO and ABMO. Now you come over here to 2px and 2py. ये अपना second combination हो गया है. Now 2px and 2py doesn't have any matching orbitals on this side. See, there are only two group orbitals, psi 1 going with 2s and psi 2 going with 2pz, that's it. Linear combination, I told you, one group orbital is going to combine with only one orbital of the central atom. Okay, multiple overlapping nahi chalega. Okay, these orbitals, okay, are going to be very faithful to their partner. Okay, so as a result of which only one combination, that's it. So that means there are no matching orbitals on this side. Okay, so that means this orbitals of the central atom doesn't combine with the group orbitals, and if they doesn't combine with the group orbitals, they will not result in bonding or anti-bonding molecular orbitals. They are just called as non-bonding molecular orbitals. Okay, and these non-bonding molecular orbitals are localized on beryllium. Okay, they are not localized on hydrogen, they are localized only on beryllium. Understood this? So in this way, what we have is 1 and 1, 2 BMO. Sigma 2s, sigma 2pz, BMO. Sigma star 2s, sigma star 2pz, ABMO. Okay, so 2 ABMO and 2px and 2py. I don't use sigma pi, nothing at all, because they are not involved in bonding at all. Okay, in some cases they do write pi, but then I feel not to involve all those complexities and all, because it's not involved in bonding only in this particular case. Okay, so that's it. Let us ignore it. So we just say 2px and 2py. So 2px and 2py are non-bonding. So 2 bonding, 2 anti-bonding and 2 non-bonding. Okay, these are going to be formed at this particular stage. Alright, so I hope you are being very clear up to this particular part. Next point, my dear friends, which I would like you to understand, and that is about the wave functions of these molecular orbitals which are formed. Okay, I given you the wave functions of the group orbitals. Okay, that was psi1 as well as psi2. Okay, but now we need to consider about the molecular orbitals. So we begin now, and that is, it's very easy. I'll just explain you. If I give you one particular set, I'm very sure you will understand the second case very easily. So the first combination we go for, psi1 is combining with what? 2s. I'll show beryllium and then HA as well as HB. Okay. Now psi1 and 2s gives you sigma and sigma star. So we have sigma 2s and we have sigma star 2s. Alright, this is the way we have. Now what we do is we need to write down the orbitals of the wave functions of the orbitals which are involved. So beryllium we have psi 2s. Okay, because this is giving you 2 of them. And for hydrogen, but simple as also, it is always psi 1s. Okay, always it is going to be what? Psi 1s. No tensions at all as far as the hydrogen is concerned. Okay? Now what we do is, we need to write down the signs now. First point is, this is not with respect to energy. I haven't drawn with respect to energy. ये मैं पहले ही बता देता हूँ. The reason because many times the students say, sir ये anti bonding है, star is anti bonding, तो anti bonding नीचे, bonding ऊपर, ऐसा कैसा? Okay, we have always learned from the lower classes that the bonding is down and the anti bonding is up. Yes, it is, but with respect to energy. Have I shown over here energy? No ways. Okay, so I have written this way. If you want, still, if you want to keep the pattern same, no problems at all, go ahead. Okay, if you want to write down sigma star up and the sigma down, no issues. But only thing is that you need to make sure that you are not making any messing around with the signs. Okay, ye yaad rakhiye. Now I'll tell you how the signs has to be there. Okay, the signs are going to come in 2 cases. In between the 2 and this. See this brackets, which is not surrounding atoms. Okay, giving rise in what? Group orbitals or ligand group orbitals, whatever we call it as. So this one, okay, are nothing but that. These are the orbitals of the central atom. And as I told you, okay, that the orbitals of the central atom combine with the orbitals of the peripheral atoms, resulting in the formation of molecular orbitals. And which one is bonding and which one is anti-bonding, that is going to be indicated by the signs. Okay, ये स्टार है, मतलब ये एंटी बॉन्डिंग है, और ये विदाउट स्टार है, तो ये बॉन्डिंग है. तो लेट अस फर्स्ट ऑफ ऑल ट्राई टू अंडरस्टैंड अबाउट दिस साइंस. तो मैंने psi 1 बोला, लेट अस रिकलेक्ट. चलो एक काम करता हूँ, मैं आपको वापस से वो डायग्राम बता देता हूँ, तो आपको ज़्यादा टेंशन नहीं होगा. ओके, ये देखिए, अगर आप भूल गए रहेंगे कि क्या ड्रॉ किया था, तो ये पॉजिटिव था. I show you with a different one, so you can recognize this very well. These two were plus and minus. Okay, this was 1s of HA as well as HB. Okay, तो अभी देखो, we are started with positive. So no need to write any signs over here, क्योंकि आपको मालूम है जब कोई भी साइन भी इससे पहले नहीं होता, so it is by default it is positive. इसलिए मैंने पॉजिटिव से ही शुरू किया था. तो अभी क्या देखने का आपको psi 1 देखो, ignore psi 2 at the moment. Psi 1 HA is positive. All right. Okay, so I'm not going to write down over here. Also, the psi 1 HB is positive. So psi 1 HB positive. Okay, 1s orbital is positive. Again, यहाँ पर भी पॉजिटिव होगा. बहुत लोग बोलते सर ऊपर पॉजिटिव है तो नीचे नेगेटिव क्यों? Okay, because in both the combination it is psi 1 only. अगर इधर नेगेटिव करते तो what do you mean to say it is psi 2? नीचे वाला psi 2 हो गया, ऊपर वाला psi 1 हो गया. कैसे? Okay, we are not changing the group orbitals, my dear friends. Group orbitals are the same. Okay, so it remains as plus and plus only. Okay, for psi 1. Abhi sign between these two. Now that depends upon whether it is bonding or anti-bonding. So now I give you a very simple logic. तो कभी आप नहीं भूलोगे, and that is bonding है तो क्या है? Strong, strength. Okay, और आपको मैं 2 ऑप्शन देता हूँ, plus and minus. And if I ask you, tell me, which is the sign, which is an indication of strength? Obviously, आपसे आंसर क्या आएगा, मैं सुन भी पा रहा हूँ आप लोग क्या बोल रहे हैं. Yes, the answer is positive. तो यहाँ पर bonding है, bonding is strength, and strength है तो it has to be positive. तो यहाँ पर positive आएगा. Okay? स्टार है, एंटी बॉन्डिंग है, रिपल्शन है, तो स्टेबिलिटी वहां पे कम हो जाएगा. इट्स फाइट, वीकनेस. तो वीकनेस के लिए कौन सा साइन आता है? माइनस. सो दैट्स इट. So psi1 plus 2s giving you sigma 2s and sigma star 2s. So this is what is the combination that we are getting. Alright. Now we go into the next one. I guess ये combination अगर आपको समझ में आ गया, the second combination is very easy for you all. And the second combination is psi2 is going to be with 2pz. तो जैसे मैं लिखता हूँ sigma 2pz and sigma star 2pz. The orbital of the central atom is going to be involved in this. So that is equal to, now please write down the wave functions. Now please make sure it is 2s है तो यहाँ पे 2pz करना है दोस्तों, प्लीज याद रखिएगा. And in this case we have psi1s and psi1s. यहाँ पर भी we have psi1s and psi1s. Please try to understand. We are writing down the orbitals of the atoms involved in this particular molecular formation. Please. बहुत लोग क्या करते हैं, they don't understand only what the concept is going on, and that's why they try to have their own conclusions and they make a mess of all these. What they consider is, I'll give you a very simple logic, and that is, most of them feel that यहाँ पे psi1 है ना इसलिए it is 1s, यहाँ पर psi2 है ना तो यहाँ पे psi2s कर देने का. बहुत लोगों को मैंने देखा है ऐसा. Okay, they write down 1s over here and यहाँ पे they write down 2s. Why? Hydrogen you are writing na at the top. So how can you write 2s when hydrogen has got only one orbital? Okay, so 2s का तो सवाल ही पैदा नहीं होता. We are writing only the orbital. तो अगर यहाँ पे psi2, psi3, psi4 भी होता ना, okay, suppose if I was talking about methane, it's not there in your syllabus, don't worry. लेकिन अगर methane होता तो psi1, psi2, psi3, psi4 होता. So in all those cases we are going to write down 1s only, because that is the orbital of hydrogen. तो please, ये भूलना मत. Try to understand. Okay, एक बार आप लोगों को अंडरस्टैंडिंग हो गया ना, आई एम वेरी श्योर यू विल बी क्रैकिंग योर एग्जाम्स. ओके, सो इस तरीके से 1s हो गया. अभी साइंस देखो, वेदर इट इज psi1 और psi2, H ऑलवेज ऐसा पॉजिटिव साइन, तो यहाँ पर इससे पहले तो कुछ लिखना ही नहीं है. हाँ, Hb नाउ psi2 में देखो इट बिकम्स माइनस, सो आई टू राइट डाउन वर्ड माइनस, और इधर भी माइनस लिखने का बिकॉज बोथ ऑफ देम आर psi2. ओके, सो इन बोथ द केसेस इट इज गोइंग टू बी वर्ड माइनस. अब इधर आ जा, बहुत सिंपल है. बॉन्डिंग एंटी बॉन्डिंग के हिसाब से दिस इज बॉन्डिंग स्ट्रेंथ. ओके, सो पॉजिटिव, ये स्टार आ गया मतलब इट इज एंटी बॉन्डिंग. ओके, इट इज रिपल्शन, इट इज अनस्टेबिलिटी एंड इट इज वीकनेस माइनस. डन. So these are the wave functions, okay, of the molecular orbitals. Okay, we are not going to write down the wave functions of the non-bonding molecular orbitals because they are not involved at all in this entire process. Alright, so this is about 2 orbitals which are being formed over here and 2 orbitals which are being formed over here. So total 4. Out of the 4, 2 are bonding, sigma 2s, sigma 2pz, and sigma star 2s and sigma star 2pz. They are going to be what? Antibonding. So I guess I'm very sure that you have understood the wave functions of these molecular orbitals absolutely well. Now my dear friends, we come to the last point of this particular molecule and the most important one, and that is about the molecular orbital diagram of beryllium hydride molecule. So now here, the most important it is. Okay, though you write down all the explanation perfect, but if you don't draw only the molecular orbital diagram, okay, then I guess it's very difficult to get marks. So this is one of the most integral part of this, whenever the question is being asked about, discuss about the bonding in beryllium hydride. Or I will say, whenever the question is asked in terms of molecular orbital, okay, and the bonding, then in all those questions, the molecular orbital diagram is going to be something which is very, very important. Alright, so we begin with, I'll explain you step by step how to draw this molecular orbital diagram. I will draw it in front of you so that you will understand how exactly to draw the diagram. Okay, rather than already drawing the diagram and then I'll tell you that this is this, this is this, उसमें इतना मज़ा नहीं आएगा. Okay, तो मैं आपके सामने डायग्राम ड्रॉ करता हूँ तो आपको पता चलेगा कि कैसे कनेक्शन किया जाता है, कौन से ऑर्बिटल का से ऑर्बिटल के साथ कनेक्शन है. ऑलराइट, सो my first point is, okay, the way the students write down the answers, because as I said, my videos are priority for student base, it's student centric, and I want the students to score marks. Of course, knowledge is also important, but then, of course, the marks, the grades, okay, they are also very important. So, how you need to draw this diagram? Most of the times what we see is that the students, okay, when they write down the explanation first, and then the time comes for drawing the molecular orbital diagram, and suppose if this much space is remaining, they will try to scribble around that, okay, and use that much. Why? Just mention for molecular orbital diagram, please turn over, or please see the next page, or please see the page number so and so. That's it. Why you want to scribble around in that very small space which is being given to you? Why? Okay, please use the entire side. If you have just completed on the right hand side and only some portion is remaining, turn over. If we have written on the left hand side and some space is there, then you draw it on the right hand side. Okay, please use the entire side for drawing it. Okay, and use a scale and all. Proper representation of the answers. Okay, it's very important. Okay, so that will also fetch you marks. Okay, and it also gives you a skill, okay, of how you represent yourself. Because chemistry is, as I said, it's much more of life. It understands the basics of life. So presenting yourself is very important. So the same thing has to be done over here. Okay, there are some students who just scribble around with the hand and they just draw like this. Okay, आड़ा टेढ़ा draw कर देते हो गया. Okay, ऐसा आंसर लिखते हैं ना कि वो टीचर को ऐसा बताना चाहता है कि मार्क्स देना है तो दे नहीं तो जाओ. They are not concerned only. Okay, that way. Please, don't keep that approach. Okay, so here I will, one point that I wanted to specify, use the entire side for drawing the diagram. Okay, now I'll show you how the diagram has to be drawn very slowly. Alright, so that you understand each and every bit of it. Okay, I don't want to just rush on with it. Okay, so we begin. The first point is, it has to be compulsory with respect to energy. Okay, okay, I don't have a scale, please excuse me. नहीं तो आप बोलोगे कि ज्ञान बहुत देता है ये खुद इस्तेमाल नहीं करता है. Okay, you can carry a scale with you, but here I don't have a bigger scale, so I'm just drawing like this. But the most important part is energy. Okay, so, and you need to show the direction. So it's very clear. Lower to higher, if we go, lower to upper level we go, the energy level increases. Okay, नीचे से ऊपर जाते energy level बढ़ता. अभी sequence देखो कैसा होता है. The arrangement. On one side there will be orbital of the central atom. On the other side there will be group orbitals. And both of which combines, so at the center there will be molecular orbital. Okay? So we are writing over here atomic orbitals of beryllium on one side. Then we write down over here the group orbitals of HA as well as HB on the other side. And at the center we have the molecular orbital of beryllium hydride, that is BH2. Okay? This is what the sequence is. On either sides they combine and at the center you get a molecular orbital. Clear हो गया यहाँ तक? Good. Next is energy levels. Energy levels में first point is the species which are involved in the combination to give a molecular orbital are belonging to different elements. One is hydrogen, another is beryllium. And when there are two different elements, so there will be a slight difference in electronegativity. At least a slight, I am saying, not always a slight. It all depends upon the nature of the elements. लेकिन थोड़ा बहुत तो difference होगा ही. ओके, जब भी हम दो अलग अलग एलिमेंट्स कंसीडर करें, कुछ फ्रैक्शंस में तो डिफरेंस रहेगा. तो जब यहाँ पर अभी ये इलेक्ट्रोनेगेटिविटी में फर्क है, when you talk about beryllium, the electronegativity value is around 1.55 and for hydrogen it is going to be 2.2. So it is very clear that electronegativity of hydrogen is greater than beryllium. Okay, now what is electronegativity? I'll tell you. Electronegativity is a tendency to, I show it in this way, okay, in the arrow form, tendency to gain electrons. Okay, it is gaining electrons. Now always remember, one important point is, gain and loss of electron is always associated with energy, always. Okay, now when I say associate with energy means what? It depends upon the process. Either the energy is absorbed or the energy is released. लेकिन एनर्जी जरूर जुड़ा हुआ है जब भी इलेक्ट्रॉन या तो एब्सॉर्ब होता है, एक्सेप्ट होता है या तो लूज होता है. अब दूसरा एक सिंपल पॉइंट बता देता हूँ ना. and that is कि जो direction है of the electron and the direction of the energy are opposite. नहीं समझा? Electronegativity is a tendency to gain electron. Okay, so if the electron is gained, मतलब electron अंदर आ रहा है तो energy बाहर जाएगा. Okay, so energy is released. If electron is accepted, the energy is released, and vice versa. Okay, मतलब when electron is out, the energy is in. Okay, तो उसको ionization potential बोलते हैं और इसको हम क्या बोलते हैं? Electron gain enthalpy. Okay, the energy released when an electron is accepted. ठीक है, this is basics. I guess everybody knows about it. तो ये ऐसे simple logic याद रखने. Okay, तो यहाँ पर देखो, हाइड्रोजन का इलेक्ट्रोनेगेटिविटी ज़्यादा है, so it has a tendency, more tendency to gain electrons, okay, and therefore more tendency to lose energy, because electron and energy are opposites. Now, if hydrogen has a tendency to lose more energy as compared to that of beryllium, तो कोई भी चीज़ अगर आप दे देते हो ना तो वो कम हो जाती है. ये आपको मालूम है अच्छी तरीके से. अगर मेरे पास ये 2 पेन है और उसमें से मैंने एक दे दिया तो मेरे पास एक ही बचेगा. तो वैसा हाइड्रोजन में, हाइड्रोजन ज़्यादा एनर्जी दे रहा है, इट इज़ गिविंग आउट मोर एनर्जी, क्योंकि उसका इलेक्ट्रोनेगेटिविटी ज़्यादा है और इसलिए वो ज़्यादा एनर्जी देने की वजह से उसका एनर्जी लेवल क्या हो गया? कम हो गया. आई बात समझ में? सो द लेवल ऑफ हाइड्रोजन एनर्जी लेवल इज लेस बेरिलियम का ऊपर. सिंपल कंसेप्ट है, वो याद रखो आप लोग. ओके, सो आई विल बी शोइंग द हाइड्रोजन लेवल्स डाउन एंड द बेरिलियम लेवल स्लाइटली अप. ठीक है, so I'll show it like this. I'll do show psi 1 and psi 2 as two separate, but most of the time they are similar also, because there is a small difference, okay, in the energy gap, because they all belong to the same element, that is hydrogen. Okay, psi 1 actually is, both the signs are same, positive, so it will combine strength, and psi 2 means the signs are opposite, so they will not combine, so weakness hai. So only a slight energy difference between psi 1 and psi 2, very slight energy difference. Okay, so I will show it like this, the orbitals of the hydrogen. Okay, now I need to show the levels of beryllium, which are higher level as compared to hydrogen. Okay, so these are beryllium. This is 2s and this is 2p. Okay, this is the energy level on which the lobes are resting. Okay, so now first combination was what? Psi 1 was combining with what? 2s. Okay, so we are going to show that connection, and that is going to give you a sigma 2s. So I am going to show over here this way. Please excuse me if it is not so straight enough. This is sigma 2s. So now see the connections please, and that is the reason I am drawing it in front of you. Okay, this is what the connection is. ठीक है? So psi 1 combines with what? 2s. Next is we have 2pz. Sigma 2pz we have. Okay, that is going to combine with psi 2. And 2pz, so it is this one. So this is it. So in this way we have what? 2 bondings. Okay, done. Okay. Next we go into anti-bonding ones. Anti-bonding mein we try to consider which one? Yes, the 2s first. So I show a level over here, and the other level over here. ठीक है? So we show the connections now. The connections will be this is sigma star 2s, so I connect it with 2s. Goes with psi 1. And then with 2pz, this is the, so this is sigma star 2s this is sigma star to pz. Okay, the connections, I guess it is very clear to you all. And I show like this, sigma star to pz. And this will be sigma star to s. So we have done with the 2 bonding and the 2 anti-bonding. Alright? Now comes the non-bonding. So they are not involved at all in the entire process. So I show a straight line like this, and 2 of them to px, to py. They are non-bonding and they are localized only on what? The central beryllium. क्योंकि वो उसके ऑर्बिटल्स, कॉमन सेंस है ना, 2p है तो उसी के होंगे, हाइड्रोजन के कैसे रहे। और कोई स्टूडेंट्स क्या करते हैं, अरे सर ये डिजाइन लगता है हमको, सर ये थोड़ा अच्छा नहीं लग रहा, इसको भी कनेक्ट करते ना, फिर देखो बहुत अच्छा दिखेगा। अरे ये अच्छा दिखने के लिए थोड़ी कर रहे हैं, रंगोली थोड़ी कर रहे हैं हम लोग। Okay, so please don't connect this with this. No. Okay, only this is localized on the beryllium. Okay, that is 2p. Okay, so this is what we have. So bonding, I write down over here NBMO, non-bonding molecular orbital, or I just write down this, and then of course with a star mark you understand. Okay, that is, it's going to be bonding, anti-bonding, sorry. So these are anti-bonding, this is bonding, and this is non-bonding. Okay, so we say the bonding ones are much more localized on the hydrogen atoms, and the anti-bondings are much more localized on the beryllium atoms. That is what we normally say. Okay, the one which are lower in the energy contribute more towards bonding, and the more which are higher in the energy, they contribute more towards anti-bonding. Alright, so this is what the entire part we have. ठीक है, ये एक बार हो गया. Okay, I hope you have understood this. इसलिए मैंने आपके सामने ये ड्रॉ करके रखा था, तो आपको समझ में आ गया कि कौन सा क्या connections है. Now, electrons. Now when we arrange the electrons, most of the time what happens, my dear friends, is that students have always in the mind that it's molecular orbital, so they show electrons in the molecular orbital. Electrons इधर गायब. अब ये जब दो combine हो गए ये मिल रहा है, तो obviously ये दोनों के electrons भी तो इसमें आएंगे. Okay, how are you going to get the electrons? ये अगर empty है, ये empty है, तो how are you going to get electrons over here? They are not going to come from heaven. Okay, so first of all please remember, एक sequence बना के रखिए. First either sides fill up with electrons, तो कभी गड़बड़ नहीं होगा. And then you arrange it at the center. So beryllium, it is 2s2, so कोई टेंशन नहीं है. Okay, hydrogen 1s1, 1s1. We are not going to show the pairing of electrons because the electrons are not localized, because the two hydrogen atoms, okay, are of the same electronegativity. So I don't show that both the electrons are paired in psi 1. No, because they are delocalized and over both the hydrogen atoms. So I will show it just as single. Okay, because the energy gap is very small. Okay, so this is what it is. So now 2 electrons over here, 2 electrons on this, so that means total 4 electrons. And 4 electrons are to enter into the molecular orbit. Now there are some rules to be followed. Rule number 1. Always the filling up of orbital starts from the lower energy. Always. So we are going to start from sigma to s, because lower energy means highly stable. The purpose of entire bonding is for stability. So always starts from the lower one. Okay? Next rule is, and that is the electron will not go to the higher energy level till the previous lower energy level is completely filled. Okay, वापस से बोलता हूँ, इलेक्ट्रॉन ऊपर वाले एनर्जी लेवल में तब तक नहीं जाएंगे जब तक नीचे वाला completely filled नहीं है. यानी in other words, if I want to arrange the electron in sigma 2pz, it is only possible when the sigma 2s is completely filled. और एक ऑर्बिटल का मैक्सिमम कैपेसिटी है 2 इलेक्ट्रॉन. यानी मैं पहला इलेक्ट्रॉन 2pz में नहीं डाल सकता हूँ, मैं दूसरा इलेक्ट्रॉन भी 2pz में नहीं डाल सकता हूँ. अगर मुझे इलेक्ट्रॉन 2pz में डालना है वो तीसरा होगा. आई बात समझ में? Okay, understood this part? So this is what you need to remember. Once again I repeat, electron filling will start from the lowermost energy level. So we are going to start from sigma to s. इधर से नहीं. And the second thing is, electron will not go to the higher energy level till the previous lower energy level is completely filled with electrons. So that means that completely filled means 2 electrons. तो 4 इलेक्ट्रॉन मुझे अरेंज करने का, तो बहुत सिंपल है. पहला इलेक्ट्रॉन गया सिग्मा 2s में, दूसरा इलेक्ट्रॉन भी सिग्मा 2s में गया, अभी तीसरा जाएगा सिग्मा 2pz में, और चौथा भी सिग्मा 2pz में जाएगा. ओके, फोर्थ आल्सो. हाँ, इफ देयर हैड बीन अ फिफ्थ इलेक्ट्रॉन देन इट वुड हैव गॉन इनटू द नॉन बॉन्डिंग, लेकिन है ही नहीं ना. वी डोंट हैव ओनली एन इलेक्ट्रॉन टू बी अरेंज्ड इन दैट. Understood this part? So this is the way the electrons has to be arranged. And then we talk about the electronic configuration, my dear friends. So when you talk about the electronic configuration, we have to, what we need to write down, simple, वापस बता देता एक रूल है, नीचे से ऊपर मॉलिक्यूलर ऑर्बिटल, अभी मॉलिक्यूल की बात हो रही है दोस्तों, सो नीचे से ऊपर जो मॉलिक्यूलर ऑर्बिटल एनर्जी लेवल के हिसाब से बोल रहा हूं मैं, वो ऑर्बिटल्स को लिख डालो इन दैट ऑर्डर फ्रॉम लोअर टू हायर, लेकिन कौन से ऑर्बिटल्स को लिखने का जिसमें इलेक्ट्रॉन्स है, बिकॉज वी आर राइटिंग इलेक्ट्रॉनिक कॉन्फिगरेशन. डोंट राइट दोस ऑर्बिटल्स व्हिच डजंट हैव अ सिंगल इलेक्ट्रॉन. हाँ, अगर एक इलेक्ट्रॉन भी है तो लिखना पड़ेगा, लेकिन अगर एक भी इलेक्ट्रॉन नहीं है तो वो ऑर्बिटल्स लिखने का नहीं है, बिकॉज वी आर नॉट टॉकिंग अबाउट हाउ मेनी इलेक्ट्रॉन्स और हाउ मेनी ऑर्बिटल्स आर प्रेजेंट, वी आर टॉकिंग अबाउट द अरेंजमेंट ऑफ द इलेक्ट्रॉन्स. एम आई वेरी क्लियर? सो नीचे से ऊपर वो सारे ऑर्बिटल्स लिख डालो which contains electrons. So there are only two of them, sigma 2s and sigma 2pz, and how many are there? 2 and 2. Okay, if you can recollect, I had written the electronic configuration of beryllium, अगर आपको याद है 2s2 और हाइड्रोजन का 1s1 ऐसा लिखा था मैंने. तो if you can just compare this electronic configuration with this configuration, okay, it is very clearly visible कि I have used certain symbols in this which I haven't used over here. मैंने कुछ ऐसे symbols का इस्तेमाल किया है in this electronic configuration जो इधर नहीं किया था. समझ में आ रहा है ना? Yes, you are very smart students, I know that. Okay, that is sigma. इधर नहीं यूज किया था मैंने. The reason is very simple कि यहाँ पे sigma जो है that is nothing but resulting in bond, और bond किधर होता है? Molecule पे होता है. Okay, it's not there in a single atom. So ये single species का configuration था, तो यहाँ पर वो sigma नहीं था, लेकिन यहाँ पर वो sigma है, which is a very clear indication that this electronic configuration is of nothing but molecule. Understood this? Next one which is to be considered is all the electrons are paired. अगर electrons जोड़ी में है, obviously there is no force of attraction at all when placed in a magnetic field, because the spin motion cancels each other. Magnetic moment zero हो जाएगा फिर. So therefore we say that they are going to be what? Diamagnetic. All electrons paired, and therefore it is diamagnetic. Okay. Now next most important thing is, according to molecular orbital theory में जो मैं बताना चाहता हूँ आप लोगों को. Okay, that is we got two orbitals containing 4 electrons which are actually being responsible for that. Abhi, when you talk about hybridization, beryllium hydride, when we talk about hybridization also, so what in that case it says is that beryllium is going to be at the center, hydrogen and hydrogen are going to be over here. It is 180 degree because it's a linear geometry. Okay, this is what the hybridization concept says, and there is equivalent HBE and BH. Okay, these ones are equivalent. But molecular orbital diagram, what it says, try to understand that, and that is the electrons which are present in this molecular orbitals are delocalized. Okay, they are what? Delocalized. That means at any point of time these electrons will be over here, at any point of time these electrons will be over here, and the bond is made up of electrons. Okay, so because of this delocalization, we say this entire concept as what? All the 4 electrons are delocalized over the entire molecule. This linear molecule which I have shown now, so these 4 electrons are delocalized over the entire molecule. They are not restricted only to the 2 electrons are only and only over here, localized over here. The remaining 2 electrons are localized over here. No, they are delocalized over the entire molecule. And therefore, since there are 3 atoms, so there will be 3 nuclei, and the nucleus is at the center, and therefore I call it as 3-centered. Okay, total electrons involved are 4, so 4 electron bonds. Okay, this is what we say, 3-centered, 4 electron bonds. Okay, which are there in beryllium hydride, linear geometry, bond angle is going to be what? 180 degree. So this is, my dear friends, the molecular orbital diagram, and then the final electronic configuration, and this point all about the magnetic properties, and please mention this also, 3-centered 4 electron bonds, and then you need to talk about the linear geometry. Okay, that is bond angle is going to be 180 degree. All the 4 electrons are delocalized over the entire molecule. Alright, so this is it, my dear friends, the bonding in beryllium hydride molecule, and I'm very sure you must have understood this very well.